It is already widely understood that in order to have a shot at hitting net zero by 2050, long duration energy storage will have to be part of the equation. Although battery deployments are the most prevalent form of long duration energy storage today, and projected to grow nearly 30% year on year for the next decade, the single most underutilized tool in our energy transition toolkit is thermal energy storage, charged by next generation concentrating solar power.
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Welcome to another edition of the Insider's Guide to Energy. This week, our energy transition conversation focuses on CSP, concentrated solar power, thermal storage of that power, and how AI and molten salts are being used to optimize the output. Our guest, Christie Obiaya, CEO of HelioGen, explains the business aspects, and she shares how the U.S. stacks up against other countries globally with our CSP deployments. We hope you enjoy this episode.
Christie, this is really exciting to hear. As a longtime energy nerd, I have to ask you, though, about CSP. This is a technology that's been around. In some ways, it's simpler and should be more cost-effective than traditional silicon PV, but yet it hasn't really scaled in the way that PV has over the last 10 to 20 years. Help us understand why that's the case and what's different now with HelioGen.
I'm so glad you asked that question. I think CSP in the US was launched in the early 2010s. At least that's when the big project started getting underway. And then, like you said, it quickly fell out of favor. But I would argue that the reasons that it fell out of favor are no longer valid. And you can see that in the fact that countries all over the world are actually deploying CSP. They've taken the lessons learned and they've been deploying at scale in many ways over the last couple of years. So the first reason why I think it fell out of favor was execution risk. A couple of the projects that were deployed faced challenges in the way that they are rolled out. And that's typical for any project that is getting rolled out at scale for the first time, right? But if we quit after the first PV project, PV might not have taken off, right? And so I think, in the last decade, the countries that have continued deploying CSP, like Dubai, South Africa, Morocco, countries in the Middle East and North Africa, Spain, and now China. China is deploying CSP all over the place. These countries have taken the lessons learned, and so the stories that people might remember about failure of tanks with molten salt storage and those kinds of things, those have technical solutions that have been successfully executed now. And so that's one retired risk that I think we can step away from and just make sure that we're using best practices and lessons learned. I would say the second reason it fell out of favor is commercial incentives. If you recall back, 10, 15 years ago, the US energy market, really global energy markets, there wasn't really a consistent commercial incentive for long duration energy storage. And CSP, the sweet spot for where CSP performs from a cost standpoint is leveraging long duration energy storage with thermal storage. And so if you think about the way that utility incentives were structured back then, it was basically up to 4 hours. And so it really incentivized PV battery and that kind of deployment. Now, when you think about what's possible, the PV battery solution is not as cost effective above long durations like 8 hours, 10 hours. And that's really the sweet spot where you can combine CSP and PV and thermal energy storage for a killer combination.
When we're talking thermal energy storage, what kind of temperatures are we talking?
It's a pretty broad range, actually. And so I would say the typical CSP, including the large-scale deployments that have been successfully commissioned and are now operating, operate anywhere in the range from 100 up to 500 or 600 degrees Celsius. And so at HelioGen, we're able to deploy that scale and that type of temperature with what's already been proven and demonstrated at commercial scale, high technology readiness level. However, we're also working on next generation storage, which has the capability of achieving much higher temperatures in excess of 1,000 degrees Celsius. And that opens up a whole new set of markets like high temperature processing, cement manufacturing, steel manufacturing, those kinds of things.
So I understand that's why you're leading with the storage pitch, because that's one of the biggest differences now,
Hmm.
that the capacity, the flexibility is more valuable than it was 10 years ago. So that makes a ton of
Absolutely.
sense. The other thing that you're highlighting is previous CSP deployments were really utility scale. And it seems like you're targeting, when you talk about industrial heat, that it's almost a behind the meter CSP. Is where's the focus? Is it utility scale, or is it industrial behind the meter?
It's both, and it's certainly not residential or small commercial scale, but both utility scale and behind the meter industrial are areas where this technology can perform well because of the fact that you tend to need to support around the clock operations in both cases, and they're at a large enough scale that you start to get the economies of scale and the benefits of deploying CSP.
One of the other textbook challenges I remember for CSP is also the need for direct rather than diffuse light. So you mentioned it's being deployed all over the world, but these are the very, very sunny, arid climates. So if you have that as a geographic constraint and you also are targeting specific industrial verticals, does that limit your deployment?
It's an interesting question. The short answer is no, because we have a huge total addressable market. Because if you think about where a lot of the world's mining operations, manufacturing facilities, those kinds of things are deployed, there is plenty of that above and beyond around the equator. And so you look at places like the U.S. Southwest and Mexico, where nearshoring is becoming a trend. The Middle East, North Africa, and South Africa. South America. There's so many mining operations in Chile where you have the highest direct normal irradiation possible. These are all areas where concentrated solar can work very well. So yeah, I don't think we're constrained from a total addressable market perspective, even though it is a different type of solar versus what PV uses.
Where are you beginning? Where are you putting your early efforts?
Yeah, a couple of initial target areas. Our strategic geographic targets include the US, so that kind of desert Southwest area, particularly in the Arizona, New Mexico type area. And that's sparked further by things like the Inflation Reduction Act, which we have disproportionate access to as a company that is not only in solar, also has thermal energy storage. We have our own manufacturing of the mirrors in the US, and we can provide the clean power that supports green hydrogen. And so all these different things can be very supportive of deployments in the U.S. The other areas that we're looking at are Australia. We have a partnership with Woodside Energy, which is the largest energy producer in Australia, and they're working with us to bring our technology into that country. In Chile, which, as I mentioned, because of the kind of behind the meter opportunities for mining and the strong irradiation there, provides a good target for us. And so those are really the areas that we're focused on. And we also recently announced a joint development agreement with a partner in Mexico who will be helping us deploy there, based on the fact that manufacturing operations are expected to grow significantly there. And many of the companies that are deploying manufacturing there have made clean energy commitments.
Going back to the storage side of this, you said long term, long duration storage. Help me
Mhm.
understand your definition of long duration storage and what that means. How do I get this solar asset, that I've heated up back into electrons?
Yes, absolutely. So anywhere in the realm of, 10 hours plus or minus several hours is kind of the realm that we're often asked to provide proposals on. And so it is beyond what is typically considered for PV battery applications. And then in terms of how the electrons or the heat goes from place to place, we start with essentially a traditional CSP configuration with a field of mirrors, and that field of mirrors will point the sun's energy to the top of a tower, and that's why we call it concentrating solar power. And so at the top of the tower, there can be all kinds of different forms of heat transfer and thermal energy storage. The most prevalently deployed form today is molten salt. Lots of commercial operational data and that sort of thing with molten salt already. And then what we're using in our next generation development of our future large scale, higher temperature product is it's a bauxite particle, bauxite being a precursor to aluminum. So it's essentially a solid particle that has capacity to retain heat at higher temperatures than what molten salt can do. And so it opens up avenues of industrial heat decarbonization at higher temperatures, as well as things like being able to use this technology for novel turbines that have higher efficiency than traditional steam turbines.
Very cool. So, how do you think about the cost? In a traditional electricity generation regime, you've got LCOE.
Mm-hmm.
Do you levelize cost of steam? Is there a unifying metric that you use to compare? And then on that metric, how much better are you than the alternative solutions?
Yeah, one of the things that we've observed is that it's most helpful for customers and for people that are already in the industry to use metrics that they're familiar with. You have to kind of bring the terminology to what they already understand. And I think, a disservice has been done to this part of the industry, CSP and long duration storage, because if you look at any third party published report, it is really hard to find any kind of data that looks at an LCOE for duration of storage greater than 4 hours. And so we've been trying to levelize the playing field, because if you compare apples to apples of other forms of storage at durations of say 10 hours, that's where you really start to see the LCOE beat alternatives. And when we talk about alternatives, the alternatives can range from other renewable energy technologies to fossil fuels. Like one example for an off-grid mining company is they're trucking in diesel 350 trucks a day, and that becomes very expensive, and they have an opportunity to decarbonize. And so those are the types of opportunities that we can prioritize as we drive down the cost curve towards our target of 5 cents per kilowatt hour for long duration storage.
So, assuming you get the cost to where your targets are, I want to go back to something that Jeff asked you about in the beginning about direct sun.
Mm-hmm.
And I want to bring in climate change, because
Mm-hmm.
there are theories that solar is going to have some differences in the future. So, how is climate change going to impact? So, let's say you set this up in the American Southwest and things change.
So one of the things that we do, we have a tool that focuses on how helping us site our projects essentially. And of course, looking at the overall DNI, the direct normal irradiation, is one of the most important factors in siting the project. But you can be within a range of plus or minus 1,000 DNI, that kind of thing, and still have an effective project. And so certainly, scenario analyses that take into account what the change could be, those are the kinds of things that we expect owner operators to want to move towards in the future, not just limited to us, but that would apply to anything, whether it's wind or solar or other renewable energy sources. The other thing that I would say is one thing we haven't talked about yet is HelioGen's enhancement to CSP is really the application of software and artificial intelligence in improving the pointing accuracy of the mirrors onto the tower. And so that's one of the things that historically was a challenge in CSP, and something that HelioGen has solved. And it's a way that we're enhancing this technology that already exists.
I was waiting for when we were going to get to the AI piece, which is great to understand. Help me understand. You mentioned the sizing. Is there a modularity, or is this a one size fits all? Can you scale up and down depending on the use case?
Yes, absolutely. And in general, we do see that there is a modularity, because there are certain constraints that make it better to be somewhat smaller and more modular than the historical mega scale deployments of the past in terms of the per tower field size. For example, there are certain thresholds, say above 300 feet, for example, that it becomes more difficult to site projects with Federal Aviation Administration and those kinds of thresholds from a permitting perspective. But also there's the fact that in general, modularity is a trend that has been increasing in the construction industry for all sorts of capital projects. And the more, my background coming from the construction industry prior to coming here to HelioGen is observing that the more you can do to design with the end in mind and to simplify the work that's actually done in the construction field, the greater certainty of outcome that you can have on schedule and cost and performance of the project.
Going to costs and considerations, you talked about the IRA before. And in our pre-conversation, I recall you talking about a lot of countries had a lead in this technology. You mentioned China in this interview. You've mentioned some
Mm-hmm.
other European projects.
Mm-hmm.
Um, Where are this supplies sourced from, and how does this align with the current, energy independence kind of strategy?
Yes, great question. So one of the benefits of our technology and the way that we're managing our supply chain is we don't actually source a lot of components from China. We have well under 10% of our total components sourced from there, and we do as much as possible leverage domestic content. So we assemble our mirrors in Long Beach, California, and we've designed that facility such that it can be modularized and taken elsewhere for efficiency purposes once we have a critical mass outside the US from a project perspective. But from a sourcing standpoint, that is one of the ways that we plan to leverage the benefits of the Inflation Reduction Act is through domestic content. And like many others, we're also still waiting for further clarity on how some of those rules get interpreted and applied. But it is something that we're very optimistic for, and we could definitely see the transition in deployment intent of owner operators and customers once the IRA was first announced in late 2022.
Sticking with the cost theme, are there economies of scale as you uh, increase deployments? We've seen that being a huge impact in solar. Is that the same thing here? And at what range does that start? So are all of these mirrors the same size, regardless of the size of project? And then help us with you mentioned 300 feet as a tower size. So what is your unit deployment? Is it a 10 megawatt? And again, are you using thermal or electrical? What's that kind of modular increment of size?
Yeah, something in the range of 50 megawatts tends to be better than, say, 5 megawatts. And certainly from a mirror size, we've taken a slightly different approach than historical CSP deployments. If you remember the CSP deployments of 10 to 15 years ago, the mirrors were often the size of tennis courts, and they had multiple facets. And one of the findings was that it's easier for those mirrors to become out of focus more quickly. And so, with the software, where we're able to control every single mirror accurately with a closed loop feedback system between cameras at the top of the tower and our heliostat field, we're able to get much more accurate pointing of the mirrors. And so, our mirrors are actually pretty much the size of PV panels that you might see on someone's house.
Have we discussed any? Are we missing any challenges? We've talked about direct insulation. We've talked about modularity, economies of scale, the pointing challenges. What haven't we discussed that have been holding back CSP that you're innovating around?
I think one thing is actually awareness of some of the solutions that have already been identified for CSP and some of the things that held it back from deployment before. And so we're absolutely on an awareness campaign, especially in the US, but also elsewhere. And so anyone who may have read about or been aware of challenges of the past or not appreciated the fact that now we have this need for long duration energy storage that did not exist or wasn't appreciated before, we have a huge opportunity to leverage this underutilized tool, which is thermal energy storage charged up by CSP.
So what one more I'm thinking of is just land use. And so, you mentioned a lot of these are remote and the ability to have really off-grid power
Mhm.
and storage. The only other alternative in a lot of those cases is diesel. And even with other technologies, it's really hard to get up to the higher temperatures. But it does seem like you really need open, flat ground rather than a rooftop system. So is that a constraint or not yet in the beachhead markets you're targeting?
It is a factor, and it is one of the things that we look for when siting projects. And so, certainly, to the extent that we have an industrial heat project, we look for adjacent land next to that project. But in general, we find that there are quite a lot of greenfield open spaces in places that have high DNI, and so we do find that there's good overlap in general. There are some use cases that are more difficult because of the need for land. For example, food processing, which often takes place in more urban areas, that would not be always a good candidate for us because the urban areas don't allow for enough space. But that challenge would also exist with many other forms of renewable energy too. And so we do use comparable land to and in many cases even less than a PV battery installation, for example. And so land is a challenge that I think that's not unique to us.
So, how did you end up getting into this space? You mentioned a little while ago you started in the construction industry. You gave a little bit of background. Maybe it's worth a little bit of your personal journey.
Yeah, sure. So I'm a chemical engineer by training, and that was a long time ago, though. So I haven't opened up the books in a while, but I think as you both are aware, it does help with fluency and understanding the industry and that sort of thing. And so my journey was when I started out as a practicing chemical engineer. I had a interesting experience traveling the world and deploying new product scale ups in facilities for a multinational consumer goods company. And it was actually a visit in 2006 to my father's hometown in Nigeria, and just having the direct perspective on the constraints to economic growth and development that occur with lack of access to clean renewable power, that sparked my interest to transition industries. And so that was when I made the shift into clean energy. And I've spent most of my career now since then in renewable energy and infrastructure and those kinds of things.
I want to highlight, though, it's Bechtel. You spent a decade,
Hmm.
and that is one of the largest, most of it. When there's a big, complex project, they're the leaders in the world for getting it done. So I really
Absolutely.
want to hear more about that experience, because very few innovators in this space truly know what it takes to get complex projects built. What were some key lessons that stuck with you in that decade of experience?
Yeah, that's spot on. It is an underappreciated fact that execution is often what makes the difference. And so, certainly, having had that 11 years at Bechtel was a very impactful experience for me. I mean, it's a world class company, and one of the things that I appreciate that they prioritize in anyone's career trajectory is getting boots on the ground construction experience. The most learning that I had while I was there was actually when I was deployed to a construction project in Baytown, Texas. And when you see the challenges that occur on a construction site, you more deeply appreciate the importance of this concept of measure twice, cut once. The idea of designing with the end in mind, the challenges around um, things that you might think to optimize for that don't turn out that way in the construction field. All of these lessons learned were really pivotal in some of the things that I look for when looking to build talented teams. And I do think that we shouldn't throw the baby away from the bathwater. I think it's often overlooked that because the oil and gas industry has been a major contributor to climate change, we've got to look elsewhere for solutions. But that industry also has an incredible pool of talent and expertise that is absolutely reapplicable to renewable energy.
Now, as we talk about renewable energy, there's no one silver bullet, in my opinion. There's going to be lots of solutions.
Hmm.
And this doesn't seem to cover everything, it covers a very specific point. Where will this end up going? Where do I anticipate seeing this in a few years from now? So let's assume you get your next generation, you get the kind of energy you want. Where should I expect to see you, and how will you play in the ecosystem of the future?
Yeah, I think that this will be one of the all of the above solutions. I think, to solve this challenge, which climate change is arguably the biggest challenge of humankind and of our time, in order to solve that, we will need all of the above approach. And many of our customers have actually told us that um, they see us as part of an overall solution as well. In fact, our current offering is a combination of CSP plus off the shelf PV, no innovations from the PV perspective, and thermal energy storage. And that turns out to be a killer combination. I think you start to see more of that in the microgrid trends, in the way that projects are being planned, where they might combine solar and wind. And so I do think that the ecosystem, the energy ecosystem of the future will include many of the tools that we're all working on now. And so I look forward for HelioGen to be part of that overall solution for climate change.
We have to give a shout out to your roots at MIT undergrad and grad school, and of course the MIT Energy Club and Conference, which you contributed to. We had another industrial heat decarbonization MIT alum. This was completely unintentional, by the way. We found you for your achievements, and then you just so happened to have done that as well. any origin stories there, or things that you keep with you now over a decade plus since then that you can trace back to those roots?
Yeah. One of those things would probably be that I think it's the case that in order to solve tough problems, you have to have diversity of all forms. You have to have different perspectives and experiences to drive innovation. And that was my experience at MIT. And it also has been, of course, proven out in studies of top performing companies. So I would say that the kind of multidisciplinary approach that MIT takes to solving problems of the energy transition is something that I've absolutely taken with me, and the appreciation for looking for talent that comes from different backgrounds. I would say yes a lot. I think there's a lot of interesting opportunities that, upon first glance, might seem like something that wasn't on your 5 year timeline, or wasn't something that you learned in class. But some of the most impactful and rewarding experiences of my career have been when I said yes to an unexpected opportunity.
Well, this has been an amazing conversation. I enjoyed finding out more about what you're doing. I want to thank you so much for being on the podcast today.
Thank you so much for having me. This has been great.
For our audience, we hope you've enjoyed this edition of the Insider's Guide to Energy podcast. If you have, don't forget to subscribe, follow us, and we'll see you again next time on the Insider's Guide to Energy podcast. Bye bye for now.